Right now, at this exact moment, NASA's Psyche spacecraft is flying past Mars at 86,000 miles per hour. It will not slow down. It will not orbit. It will pass within 350 miles of the planet's surface, steal Mars's gravity, and use it like a slingshot to accelerate toward a destination 280 million miles away. The entire encounter lasts 3 minutes. Mars is not the destination. Mars is the shortcut. And what Psyche is actually hunting is a world that should not exist. A 140-mile wide asteroid made almost entirely of iron and nickel, the exposed core of a planet that was destroyed billions of years ago. A world worth $10 quintillion, more than the value of every economy on Earth combined. This is happening today, May 15, 2026. And here's why it matters. Psyche launched from Kennedy Space Center on October 13, 2023, strapped to the top of a SpaceX Falcon Heavy rocket. The mission had one objective: travel to the asteroid belt between Mars and Jupiter and study an object that planetary scientists have been obsessing over for decades. An asteroid named 16 Psyche. Not because it is large, though at 140 miles across it is one of the bigger objects in the belt. Not because it is close, though it sits in a relatively accessible orbit, but because of what it is made of. Most asteroids are rock. Some are ice. A few are mixtures of both. Psyche is metal, almost entirely metal. Iron, nickel, and trace amounts of gold, platinum, and other rare elements. It is one of the only objects in the solar system where you can see a planetary core exposed and accessible, not buried under thousands of miles of rock and magma like Earth's core, just sitting there, floating, waiting. The leading theory is that Psyche is a fragment, the leftover core of a planet that tried to form in the early solar system but was destroyed before it finished. Something, likely a series of catastrophic collisions, stripped away the outer rocky layers, the mantle, the crust, everything, and left only the dense metallic heart behind. What we are looking at when we look at Psyche is the guts of a dead world, the kind of material that sits 1,800 miles beneath your feet right now, unreachable, invisible, known only through seismic waves and computer models. Psyche is the only place in the solar system where we can study that material directly. And to get there, NASA had to use Mars. Here is the problem. Psyche the asteroid sits roughly 280 million miles from Earth at its closest approach. That distance varies depending on where both objects are in their orbits, but the average is somewhere in that range. A spacecraft cannot simply point itself at Psyche and fire its engines until it gets there. The fuel required would be enormous, the travel time would stretch into decades, and the cost would make the mission impossible. So instead, NASA uses gravity. Gravity assist. It is one of the most elegant tricks in spaceflight. You aim a spacecraft at a planet, not to land, but to pass close enough that the planet's gravity pulls on it. As the spacecraft swings around the planet, it borrows a tiny fraction of the planet's orbital momentum. The planet loses an infinitesimally small amount of speed. The spacecraft gains a significant boost. It is a free acceleration. No fuel burned. No engines fired. Just physics. The maneuver was pioneered in the 1960s and perfected during the Voyager missions in the 1970s. Voyager 2 used gravity assists from Jupiter, Saturn, Uranus, and Neptune to reach parts of the solar system it could never have accessed on its own fuel supply. The technique works because planets are massive and spacecraft are not. Stealing a little bit of momentum from Jupiter does not slow Jupiter down in any measurable way. But for a spacecraft, that stolen momentum can mean the difference between a mission that takes 6 years and one that takes 12. Psyche, the spacecraft, needed that boost. The original trajectory required it to fly out to Mars, use the planet's gravity to bend its path and increase its speed, and then continue outward toward the asteroid belt. Without the Mars flyby, Psyche would need roughly 50% more fuel than it is carrying. The spacecraft would be heavier. The launch vehicle would need to be bigger. The cost would balloon, and the timeline would stretch. The gravity assist saves 3 years of travel time and millions of dollars in fuel and launch expenses. But gravity assists are not simple. The margin for error is razor thin. Psyche has to arrive at Mars at exactly the right time, traveling at exactly the right speed, on exactly the right trajectory. Too high, and the gravity assist does not provide enough acceleration. Too low, and the spacecraft dips into the Martian atmosphere and burns up. The difference between success and catastrophic failure can be as small as 10 miles out of a 2-million-mile approach. NASA has been calculating this trajectory for years. Engineers at the Jet Propulsion Laboratory in Pasadena ran simulations thousands of times, adjusting for every variable they could measure: the gravity of the Sun, the gravity of Earth, the gravity of Jupiter pulling on everything in the asteroid belt, the position of Mars in its orbit, the exact mass of the Psyche spacecraft down to the kilogram, the solar radiation pressure pushing against the solar panels. Every factor had to be accounted for. Every number had to be perfect. And today, that math is being tested. Right now, mission controllers at JPL are monitoring Psyche as it passes Mars. They are receiving telemetry from the spacecraft every few seconds. Speed, altitude, trajectory, system status. The spacecraft itself is autonomous during the flyby. There is no time for human intervention. The radio signals traveling between Earth and Mars take roughly 13 minutes each way. By the time Mission Control sees what is happening, it has already happened. The spacecraft has to execute the maneuver on its own. Psyche is not taking photographs of Mars. This is not a science mission for the Red Planet. The cameras will snap a few verification images to confirm the spacecraft's position and orientation. But that is it. Mars is a tool, a gravitational stepping stone. The real target is still 280 million miles away. As Psyche swings past Mars, the planet's gravity pulls it forward, accelerating the spacecraft by roughly 2,000 miles per hour. That does not sound like much compared to the 86,000 miles per hour Psyche is already traveling. But in space, every bit of speed matters. That extra velocity changes the spacecraft's trajectory, bending its path outward toward the asteroid belt, and shaving years off the total travel time. The flyby itself lasts only a few minutes. Closest approach happens in a blink. Then Psyche is past Mars, moving away, continuing on a trajectory that will carry it to the outer solar system. If the math was right, the spacecraft is now on course for a rendezvous with the metal asteroid in August 2029. If the math was wrong, the mission is over. So why go to all this trouble for a chunk of metal floating in the asteroid belt? Because Psyche is not just valuable. It is scientifically irreplaceable. Every rocky planet in the solar system, Earth, Mars, Venus, Mercury, has a metal core. We know this from gravitational measurements and seismic data, but we have never seen one. The cores are buried too deep. Earth's core sits 1,800 miles below the surface. The pressure down there is over 3 million times atmospheric pressure at sea level. The temperature is as hot as the surface of the sun. We will never drill that deep. We will never send a probe there. The core of our own planet is permanently out of reach. Psyche, the asteroid, is different. It is a core that is not buried, a core that was exposed by violence, stripped bare by collisions in the chaotic early solar system, and left floating in space where we can actually study it. If the theory is correct, if Psyche really is a planetary core fragment, then studying it gives us a window into the interiors of every rocky planet that exists. It tells us how planets differentiate, how heavy elements sink to the center, while lighter materials rise to form crusts and mantles. It tells us how magnetic fields are generated in molten iron cores. It tells us what Earth looked like in its infancy, before the crust solidified, before the oceans formed, before life began. And then there is the value, $10 quintillion. That number gets thrown around a lot, and it is worth understanding what it actually means. It is an estimate based on the current market value of iron, nickel, platinum, gold, and other metals, multiplied by the estimated volume of those materials in the asteroid. It is not a realistic number in any economic sense. If you somehow hauled all that metal back to Earth, the market would collapse instantly. Scarcity drives value. Flood the market with quadrillions of dollars worth of metal, and the price per ton drops to nearly nothing. But the number is useful as a thought experiment. It tells you the scale of resources sitting in the asteroid belt. Psyche is not unique. There are thousands of metal-rich asteroids out there. And if humanity ever figures out how to mine them, how to refine metals in space and use them to build structures in orbit instead of hauling everything up from Earth's gravity well, then those asteroids stop being curiosities and start being infrastructure. The metal in Psyche alone could build millions of spacecraft, space stations, solar arrays, and habitats. It could supply an off-world economy for centuries. That is the long-term vision, but the short-term goal is science. Psyche, the spacecraft, is not carrying mining equipment. It is carrying cameras, spectrometers, magnetometers, and a gravity science instrument. Some scientists think it might be a pile of metallic debris that clumped together after multiple collisions. Others think it could be a hybrid object, part metal, part rock, that lost its outer layers through a different process. The only way to know is to go there and look. Today's Mars flyby is the moment that makes all of that possible. Without this gravity assist, Psyche cannot reach the asteroid. The mission depends on this 3-minute encounter with a planet that has nothing to do with the science objectives, but everything to do with the physics of getting there. Right now, Psyche is moving away from Mars. The flyby is over. The trajectory has been adjusted. The spacecraft is on course. And Mission Control is analyzing the telemetry to confirm everything went as planned. If it did, then in August 2029, Psyche will arrive at the metal asteroid and begin the most detailed study of a planetary core ever attempted. We will see a world made of iron. We will measure its density, its magnetic properties, its surface features. We will learn how planets are built from the inside out. And we will take the first steps toward understanding whether the resources floating in the asteroid belt could one day support human civilization beyond Earth. Mars was just the shortcut, the checkpoint, the gravitational springboard that sent Psyche toward a destination no spacecraft has ever visited. A world that should not exist but does. A fragment of a planet that died 4 billion years ago, preserved in the vacuum of space, waiting to tell us its story. The flyby happened today. The real journey is just beginning. And in 3 years, we will finally see what is hiding at the heart of a dead world.